Okay, this is the Math 136 midterm review, version A. Start off here with number 1, where we are going to simplify some exponents. We need to use the properties of exponents here, and there are a few different approaches of how you could start this one. What I'm going to do is first just address that negative exponent. So I'm going to leave this first factor the same, just copy that down. Remember that that negative exponent kicks that entire piece down into the denominator. Once I move it to the denominator, it's not a -4 anymore, it is a +4. And when I've taken that first little step, what I recognize right away is now I have both the numerator and the denominator are raised to the same power. So I can rewrite this. It's basically a single fraction raised to the 4th power. The reason I'd like to do that is because now I can simplify what's inside those brackets before I go in and apply that exponent. So notice here we have a 3/12, so we can reduce that right down to a 4. We have on the top x to the 4th, on the bottom x. If we are dividing those common bases, we subtract those exponents. So x to the 4th, x to the 1st leaves us with x to the 3rd on top. And then we'll do the same thing with the y's. This time we have more on the bottom. We have y to the 5th on the bottom, y to the 3rd on the top. If we subtract, that means we have 2 left over, and those end up on the bottom. Whole thing is still raised to the 4th power. And now I'm going to go ahead and apply that exponent. So remember when we have stacked exponents, oops, that's not how I wanted to write that. Here we go. There. When we have those stacked exponents, to simplify, what we're going to do is multiply those together. So up top, we end up with x to the 12th. On the bottom, 4 to the 4th. Well, let's just check it out to be safe. Oops, no. 4 to the 4th is 256. And then y, again, we multiply those exponents. There's our answer. The other approach you could have taken is gone ahead and applied those exponents right away. It just takes a little more simplifying. That way you end up with some big numbers. Okay, number 2. We're going to simplify this radical. So I'm going to start out here by making a prime number tree for that 48. I'm going to work on the 48 first. I need to take the cube root of it. And it doesn't matter what two values you start with here. I'm going to start off with 4 and 12. 48 is 4 times 12. 4 is 2 times 2, and those are prime numbers, so we're done there. 12 is 3 times 4. 3 is prime. And 4 breaks down one more time into 2 times 2. Okay, since we are trying to take a cube root of 48, we are looking for factors that come in sets of 3. And look right here, I have 1, 2, 3 2s. That's one set of 2s. So one of those 2s gets to come out of the radical. These other 2 have to stay inside. And you multiply them back together. A 3 stays in and a 2 stays in, so 3 times 2 is 6. That takes care of that 48. Now we have m to the 11th. So the question we ask ourselves is, how many sets of 3 are there in 11? One way to answer that is through division. 3 goes into 11 3 times. So that means m to the 3rd gets to come out of the radical. But that doesn't take care of all 11 of them. That only takes care of 9 of those m's. So there are still 2 left inside. We need to answer the same question for n. How many sets of how many sets of 3 are in 24 n's? And that comes out nice and even. There are 8 of them. So n to the 8th comes out, and that is our final answer. Next up, we have some fractions that we want to multiply here, rational expressions. So when we see something like this, when we are multiplying fractions, remember that we just multiply straight across the top and straight across the bottom. Instead of doing that directly here, what we really want to do is factor everything we see up here. So let's start with this first 2x squared minus 98. So the first thing I notice is that 2 and 98 are both even. Okay, so I can factor that 2 out front. It's the greatest common factor. And left behind is x squared minus 49. I'm just going to go ahead and work my way across the top. I can factor that next expression also. 3 can be pulled out. I have x plus 4 left behind. And then we'll work on that denominator. X cubed minus 343. X cubed with two terms makes me think of a difference of cubes. Let's see, is 343 a perfect cube? Let's find out. If we take the cube root of 343, we get 7, yes. So that is the difference of two cubes. And we have a formula for that. It is a minus b times a squared plus a times b minus b squared. Okay, so that was this first expression factored. And then we do want to factor that last part too. The first thing I notice, that is a trinomial, but before I worry about that trinomial, I see I can factor a 2 out of every one of those terms. So that becomes x squared plus 11x plus 56 divided by 2 is what, 23? It's a little early for me. My brain's not working quite yet. Okay. Now we did some great factoring there, but we're not quite done yet because this part and this part can both be factored again. So let's look at that one more time. So we have 2, and up here on top, difference of squares. And you know one more thing I'm going to do? Actually, I'm going to back up. 2 times 3, that's 6. I can put those together in the front so I don't have those two coefficients. And then I have an x plus 4 all over. This 2 back here, I'm going to bring that in the front also. I have x minus 7. I have x squared plus 7x minus 49. And then I'm going to see if that last piece factors one more time. X. Okay, did you guys catch my mistake? I'm just now catching it. Like I said, it's a little early for me. This should have been 28, not 23. 28, fix that up. Sorry about that. Fix it on your paper if you're working. 28. We need to break that into two factors, and I'm thinking a 7 and a 4. If I make those both positive, that will give me that positive 11x in the middle. This is looking good. So now that we have everything fully factored, that's when you get to do the fun part. We get to cancel any factors that are common to the top and the bottom. So we got an x minus 7 here that goes away. We got an x plus 7 here that goes away. An x plus 4. And the last thing I want to deal with is here. 6 divided by 2 is 3. So our final answer has that 3 up in the numerator and the x squared plus 7x minus 49. Now, why didn't I factor the bottom of that? It is a trinomial. It doesn't look like a trinomial. It is a trinomial. But I can tell pretty quickly in my head that that one didn't factor. In fact, when you use that difference of cubes formula to get that result, I have never seen a trinomial that factors after you apply that formula. So there is our final answer. Number 4, solve this equation and check your solution. So we're changing here. We were just simplifying. We weren't solving in those first 3 problems. Now we're going to start solving. This is a rational equation, meaning we have some variables there in the denominator. And to solve this rational equation, what we need to do is we need to cancel out those denominators. So what I want to do here is I want to multiply this entire equation by an expression that is going to cancel both denominators. And in this case, that is just the product of those two denominators. So I'm going to multiply every piece by that. I'm going to go ahead and write this out long ways so you can really see what's going on. So here's my first fraction. And I'm going to multiply that one by 2x plus 1, 2x minus 1. If you want to, put that over 1, because that's really a whole number. We multiply so that helps you line up your fractions when you're multiplying. And then we had minus 8x over 2x minus 1, and that gets multiplied by that same thing. We have our equals -4, and that, even though there's no fraction over there, we still got to multiply that, or we've messed up our equation. We got to multiply everything by the same to keep it equal. Once we write it out like that, we can see how these fractions are going to go away. This 2x plus 1 cancels, and we are left with 7 2x minus 1. Same thing here. This time the 2x minus 1's canceled. Don't lose that sign. We have a minus 8x times 2x plus 1. And then over here on the right-hand side, nothing cancels. We are going to have to just go ahead and multiply that all out. So now our fractions are completely gone. We can carry on with our solving. Let's go ahead and do some distribution here. So we get 14x minus 7. We're distributing a negative 8x, so minus 16x squared minus 8x. Over here, I like to FOIL before I distribute that -4, but you could really do it in any order. So we end up with -4 times 4x squared. We'd get a minus 2x and a plus 2x, so those go away, and -1. And then we're finally ready to distribute that 4. In that same step, I do notice over here on the left, I have a couple like terms. Let's go ahead and put those together. So 14 minus 8 is 6x minus 7 minus 16x squared equals -16x squared plus 4. Now we'll start moving some things around, gathering up our like terms. The first thing I'm going to do is add that 16x squared to both sides. And we'll come up over here. When I do that, they nicely cancel each other out. We get 6x minus 7 equals 4. So I'll add that 7. We get 6x equals 11. Divide by 6. X equals 11 over 6. There is our answer. Hold on. We do need to check that answer. At a minimum, we need to check and make sure that that doesn't make the denominator of these fractions 0. I'm just going to go ahead and check it all the way on my calculator because it's pretty easy to plug that in. 7 over 2 times 11 over 6. Calculator can handle those complex fractions, no problem. There's our first part, minus another fraction, 8x, but x is 11 over 6. And then in the bottom, we have 2 times 11 over 6 minus 1. And if this checks out, that should equal -4, and it does. Yay, that is a check. So that is our final answer. Okay, next up we have a little formula here, a whole bunch of letters in there, and we want to solve that formula for C. So we need to get C isolated by itself. Right now, C is trapped inside these parentheses. We have two choices for how we can get C free out of the parentheses. We could distribute that 1/4, okay, but then we're going to have a fraction in two places. I really prefer just to clear that fraction out. If we multiply by 4 on the left, sorry, that's the right. Then we also need to multiply by 4 on the left, and that just clears it right out and it's gone. So that leaves us with 4b, cancel, cancel, equals AC plus BC. Excellent. Solving for C. Right now we have C appearing in two separate terms. We can't solve for C when it's in two locations like that, so we use our favorite math trick, which is factoring, to put that C into one place. We pull it out front. And again, solving for C, it's now C times A plus B. So to get C alone, we'll divide both sides by A plus B. And that's it. That's our final answer. We get C equals 4B over A plus B. There we go, because those cancel. Okay, let's do number 6. This is kind of a mixture type word problem. Number 6 and number 7 actually work very similar to each other. Number 6 says, a nursery has $65,000 of inventory in dogwood trees and red maple trees. The profit on a dogwood tree is 29%, and the profit on a maple tree is 16%. The profit for the entire stock is 20%. How much is invested in each type of tree? So I'm going to start off by setting up some little information here. I'm going to pick X to be the number of dogwood trees. And if that's the case, that X is not the number of trees, sorry, it's the dollars we have in dogwood trees, how much money we have in dogwood trees. And if that's the case, that X is going to be the amount of money I have in dogwood trees, that means my total amount of money minus X is going to be the other type of tree, which in this case is the amount of money we have in those red maples, okay? Then I'm going to use those two expressions and the percentages given to us in this problem to set up our equation. So our equation is going to be based on the amount of profit we make from each type of tree. We get a 29% profit from our dogwood trees. So that would be 0.29 times X, the percent times the amount we have in those trees. Plus, we get another 16% from our maple trees. So 0.16 times the amount we have invested in maple trees. And when we add those two together, those have to add up to our profit in the entire stock, which is 20% of 65,000 is our entire stock. Don't forget to multiply over there too. We'll go ahead and do a little simplifying. We can distribute here. So 0.16 times 6,500, or 16% of, 65,000 is 1,400. And 20% of 65,000 is 13,000. Then we can go ahead, and here we have two like terms. We can put those together. So 0.29 minus 0.16 is 0.13x. Then we'll want to subtract that 10,400 from both sides. $2,600, and then last step, divide both sides by 0.13. And it turns out we have X is 20,000, okay? So look back at the top. We said X was going to be the amount we have in our dogwood trees. The question is how much is invested in each type of tree. So for the maples, we have to do that quick little calculation. And that means that we have 45,000 in maple trees.